All right, let's talk about a rule. Not just any rule, but maybe the strictest, most important rule in the entire universe. It governs literally everything, from the engine in your car to the life and death of stars. So let me start by asking you a question, one that people have been obsessed with for centuries. Can you actually build something, a machine, anything, that just creates energy out of thin air? Well, the universe, it has a really simple, really clear, and totally non-negotiable answer to that question. No, not a chance. And that single, powerful word is the key to understanding, well, everything we're about to get into. Now, this universal no has an official name. It's called the First Law of Thermodynamics. You can think of it as the ultimate law of conservation. It basically says you can't make energy and you can't destroy it. All you can ever do is change it from one form to another. Like taking the chemical energy in gasoline and turning it into the kinetic energy that makes your car go. Okay, to really wrap our heads around this, let's try something. Forget the physics for just a second. I want you to imagine the universe is like this giant bank. The first law is its one and only rule, and we're about to become its accountants. And every good accountant needs a ledger, right? A way to track the money. In our cosmic energy bank, this simple little equation is our ledger. Now, I know equations can look a little intimidating, but trust me on this. It's really just a basic balance sheet. So let's break this ledger down piece by piece. That delta U symbol, that's the change in the system's internal energy. Think of that as your final account balance. Q is any heat you add to the system, those are your deposits. And W is any work this system does, those are your withdrawals. So your final balance is just your deposits minus your withdrawals. See? Simple. All right, got your accountant hat on? Good. Let's crack open a few case files and see how this ledger actually works in the real world. First up, the isothermal process. This is any situation where the temperature stays perfectly constant. Here's the thing. A system's internal energy, or account balance, is directly tied to its temperature. So if the temperature doesn't move, the balance can't change either. That means our change in energy, our delta U, is zero. Nothing's changed. So if the balance is zero, what does that mean? It means Q has to equal W. In our bank analogy, every single dollar you deposit is immediately spent. All the heat energy you add gets instantly converted into work. A perfect example is a gas expanding inside a piston while you keep the temperature steady. Okay, case file number 2. This is called the adiabatic process. This happens when a system is perfectly insulated. Think of it like it's inside a superthermos. No heat is allowed in or out. Adiabatic just means no heat transfer. So looking at our ledger, Q, our deposits, is a big fat zero. There's no money coming into the account at all. The equation gets even simpler. Delta U equals negative W. So what's the upshot? It means if the system has to do any work, if you want to make any withdrawals, it's got to pay for it straight out of its own savings. The internal energy has to go down to get the job done. You see this happen when a gas expands or gets compressed really, really suddenly, so there's just no time for heat to move around. And that brings us to our last case file for today. Let's look at the isochoric process. This is what happens when the volume of our system is totally locked in place. It cannot expand or contract. So imagine a sealed, super rigid container. If the walls can't move, the system can't do any work by expanding, right? That means W, our withdrawals, is zero. You literally can't spend anything. So our ledger simplifies one last time. And the result is, well, it's beautifully simple. Delta U equals Q. Every single bit of heat you pump in, every single deposit, goes straight into the account balance, just raising the system's internal energy. The classic example, heating up a gas in a sealed metal tank. It gets hotter, its energy goes up, but because it can't expand, it does zero work. Okay, so we've looked at these different scenarios, these individual accounts under all these different conditions. Now it's time to zoom out. Let's run a final audit and look at the balance sheet for the whole cosmic bank. Just look at this table. This is where you really see the power of that one simple rule. Notice how the same exact law, delta U equals Q minus W, just elegantly adapts to every single situation you can throw at it. Whether your deposits equal your withdrawals, or you're spending from savings, or every deposit just goes into savings, it's all the same law, just wearing different hats. It's one universal rule for all energy transactions. So what's the big, ultimate takeaway from all this? It's that the cosmic books, they always balance
Always. The total energy of a system plus its surroundings is constant. It just gets moved around and changed into different forms. It's never, ever created or destroyed.
And that leaves us with one last, kind of huge question. If the total amount of energy never changes, if it's all still out there somewhere, then why can't we just collect it all and reuse it forever? Why do we have things like energy crises? Well, it turns out the universe has another rule for that. And that is a story for another time.